Hi.
Hi, sir. Good morning.
So,
Hello.
yeah, so Monica and Tejashwani, do you know where Anusha and Sandeep is, or are they going to join?
Hmm. We'll
I
ask and
don't know,
let you
sir.
know.
Okay, sure. And meantime, I will start in a couple of minutes, or in another minute. I'm going to start with the class.
Okay, sir.
Uh, Okay, let's start with the class today. And yesterday I was doing this priority queue and I was not able to do a PQ. It was a silly mistake that I was doing. I was doing inside a class, but I should have done inside a method. So you can see this one, if I had not written public static void main, now I'm doing a string args and I'm doing this. Now you can see I will be this will let me to add and everything has come. So add, suppose I'm doing a, it's a similar thing, something called add. It has, I think, b eq dot add, maybe d. Now let me print this out. Priority q q, and we have this method called peak. Let's see what is this peak does. Let's check what this peak does. If I can check, see, peak means it will just pick you the first element, that is A. If I had written here C, see, it has picked me B. Now there is also, I think there is also called poll. Let's do it. Poll. Let's check what this poll does. Again, I'm printing the same priority queue after poll. See, it is pole means it is deleting your element that your. Do you remember that Monica has told that a queue is a first in first out? So people standing in the line or in a queue, the first person who is present at the uh, first of the queue, he is served first. So when I'm doing a poll, so I am deleting the first element using the poll. So when I'm doing pq.poll, it is deleting me the first element that is there. Anyways, this I have done. And next we are going to do your array dequeue. Suppose similar, we have seen this. Let me open the notepad. See, we have this called array dequeue. Yeah. Where is the interface that I've written? Yes, there it is. Now we are moving to the next thing is called array dequeue. Array dequeue is similar. It extends the abstract collection and implements dequeue, this particular dequeue. Let's do let's do an example of the array dequeue. These are almost similar. These collections are almost similar. So instead in the priority queue only I'm doing, instead of writing a class, I'm doing the array dequeue here. Array dequeue. These collection sets are almost similar, and here instead of add we need to write something here called, let me change the array dequeue, ad, maybe adq. So adq dot we have called push. See, we have push. We have, let me push a b c e and e. Let's check this system. Let's do a sysout, and we are going to do this adq. We are printing this now. Remember, we have a push pop concept. Push pop concept is in this array dq or something I'd written. Okay, uh, I'm not getting where I had written this particular called array dq or
In new 4.
yeah, I got it. Array dq extends this, and remember there is a concept in queue, as we have told that the person who comes first is served first. So we can just push means push your element. We have this two concept. Push means add the element either either at top or at last. So let's check when we are adding this. When you are adding this, see, this is printing me from this way, EDCPA. What happens in a queue? Whenever you are adding the elements, okay, the first element to be added is A. You are adding this like A, then the second element is added C, then D, then E, then this particular called E. So as it is a queue, so what happens? The first element that goes in will be served first. So in a stack, like let me go to the pent. If it is your queue here, okay, and you have some, you are keep on adding this. When I'm pushing this all, when you have added A, what happens? It just goes. It's not like this. In the array list, if you add A, B, C, D, it adds like this A. If it is an array list, then you have something called B, then you have C, then you have C. It's going to be keep on adding in the memory in this way. But when you are adding it in a queue, what happens? It, the A, when you push A, this A, when you push it to A, first it's get to added here, okay? Then you are going to push A, sorry, push B. First you have added A in your particular called array DQ. So it happens that it got added here. Now you are pushing called B from the program. Now you are pushing B. What happens? This A goes here, goes to your next memory location. This particular case, A goes here and B has been pushed here instead C, the difference. Now when again you add C, what happens? This A, this particular A comes to here, means the third location, then B comes here and C is added. So this is the concept of pushing inside a queue. And pop, let's check the pop. Suppose I'm doing a pop. First, let me check that whether the elements are present. So I need to do a pick, adq.pick. Yes, if it is not null, then let's do a sysout. I'm doing a pop. Or let's do the first pop. Then we will do this. Let's do this and check. See, we are popping the first element here. So in this array DQ, it happens. In this array DQ, it happens when you are popping it. See, let me go. When you are pushed and only two elements are there, suppose it is A, B, C, D, E already are there, so your element has been all has been pushed, and let me write it here. Suppose it's A, it's B, C, D, and let's do E. So when you are popping it, means you are deleting. Popping is just deleting either from this end or at the back end. When you are deleting this first element is getting deleted. You can check. The first element that is getting deleted is E. Then my element that has means the array DQ that is present is uh, B means C B A D C B A. Again, if I had popped it, then you check your D element would be get removed by deleting an element. So your D element will get removed by this way. Let us check this. See, now that remains is your CBA. So this is the concept of array DQ, and this is the difference between your general array list and this. If you had added any array list here, then the elements would have been added in this way: A, B, C, D, E. But you are pushing, that means you are pushing the A and to up to here, then it is getting E. So when you are popping, then E is getting first deleted. So is it clear, this array DQ difference between the array list and the array DQ?
Yes, sir.
Okay. Okay. Now we have seen that to transverse this particular called your means the collection, we have used for each loop. For each loop is the easiest way. Suppose I think I have used it here. Yeah, you can check. Easiest way to transverse these particular elements. Now I can use iterators instead of this, but iterators has become an old type of old method to means old concept to transverse the elements. We use the for each loop to transverse now, but let's check with the examples of the iterators. So you need means whenever you are using an iterator, remember, let's write this first. It is in the fourth. Let's do iterators. We use iterators. It allows for bidirectional transversal of, suppose we are doing a array list or a list, so I'm checking it only of list and the modification of elements. Suppose if I had done something here called iterator, remember these are generic interfaces which are declared, which is declared as, this iterator is a generic interface which is declared as this way: interface iterator E. This is a placeholder. This will contain your either list or set or anything that you pass. So let's use an iterator. So before using an iterator, you need to do first new one needs to start the collection by calling the collections iterator method. Let's do first this, then I will go to the second point. Suppose I had something called B, C, D, E, and then I have also added again D, or let's see, A. Instead of doing this use the iterator. What I have written is one needs to start the collection by calling the collections iterator method. So let's call the iterator method. Suppose I'm printing first this, let's me print this AL, then I'm calling this iterator method iterator. This is the string because these have all string. So I'm, I'm making an object which will call this particular called AL array lists iterator method. See this method I'm calling. So this is the first case that I am doing. Now the second step that one needs to do is set up a loop that makes a call to has next. What this has next does? This does means have the loop as long as this has next is true. That means has next checks your element whether an element is present inside your array list or a set or any of the collections that you are using. So when you are setting up a loop to call this particular hash next, it checks whether this array list has more elements inside it. If it has some more elements, then it will return true. Otherwise, it will return me false. So let me do the while loop here. While this object I have already created, while iterator dot has next, this is returning me a boolean whether this particular has an element or not. And each element, suppose the third point transverse is within the loop, means within that I have set up this has next, within the loop obtain each element by calling next. Suppose I'm calling a string s equal to iterator that dot next. Suppose if I'm calling this and then I'm printing this s. Let's take this. See, It is printing me the initial size 0, then printing me this C, D, E, F. Then I'm doing iterating each. So I'm calling the iterator method using this particular called AL, the list that I have, the iterator method, and I'm checking whether these elements have the next element. Then I'm doing a string iterator dot next, and then I'm doing a sysout. So you can also modify using this iterator. You could have also modified your elements. Suppose if I had given this as a iterator dot, sorry, hmm, we have a remove elements here. See, I was checking this whether I have the remove elements. See, I can remove this particular element, and it is going to modify this particular array list or this particular thing here. Or also you can just do this also, like iterator dot next. Let me do this iterator, and let me break this. You can just modify, and let's check what happens. I'm breaking the loop after getting the first element. What happens? See, it has removed me the first element. And remember, with this method, you have another method that is called list iterator. I think when you are working with the list or array list, you have this particular called list iterator. See, you have this particular list iterator too. And this list iterator, if I'm using instead of iterator, this will help. Uh, uh, This will also help me to get the elements of a list one by one, or also you can do means also you can just provide that whether this can be transversed in a way. Suppose I told you to do a list iterator, means to transverse it in a backward direction. So this is to the forward direction what we are using. Let's check it has something called has previous or something called, no, it has only your particular called has next. Okay, this is the mistake I'm doing. This is the iterator what we have told. Now for the list iterator, similar, we have called list iterator. Let us check the list iterator what it does. See, the list iterator, you can transverse it to the forward using the has next, or also you can transverse it to the backward using the has previous. This is the way we can transverse it to the backwards, or you can use this particular called has next to the forward direction. So let's do, if I do the list iterator in this fashion, and let us print this. See, we have this least iterator too, and let's print this s. It is not. Can you tell me why hasn't it printed anything? Anybody? When I have
Is
done it?
iterator.next
Yeah, yeah. It should be
previous.
previous. Still, it has not printed me. Any guesses? See, I'm doing here. This is my array list. How many are there? A, B, C, D, E, F. C, D, E, F, A, C, D.
For the first element, does it have any previous? Does it?
Yeah, that is correct. But let me show you how this is working.
Okay.
Suppose it is C in the array list, then it contains your D, then it contains your E, it contains your F, I think then it contains your F, then it contains your A. This is my array list. So what happens? Whenever I'm doing, now my pointer, all my list is pointing to here. When I'm doing it here, so it is pointing me at this particular location at C. So you can see I do not have anything to that particular called previous. When I'm doing a iterator dot next, you can see this particular. Suppose I was doing iterator next as next dot next. Let's check what it does. See, it is printing me this particular called A, B, C, D, E, F. Okay, let me do with this iterator dot previous. Now dot previous. I'm doing a sys out. Backwards. Let's check if it is printing me. See, it has printed me now. It has printed me from the backwards. The thing that is being done here, when you are doing this itr dot next, what happens one by one, this pointer, this particular pointer. Now, when you're doing the first next, itr dot next, it is coming to here. Now again you are doing the pointer again in the loop, it is next, so the pointer is moving. Whenever you create an object like this or call a method itr next or itr, remember your pointer always remains at the first position. Now you are moving your pointer doing next. See, you have done this itr dot next, so it has moved your particular called d. Now whenever it finishes, the pointer moves from here to your last. to this particular scenario. It moves to this particular last. Now, when you are doing a backward, like previous or this, it is moving. Now it has moving, it can move to the first. Now see, suppose if I had moved only at one point, then I had done a break. Let's check. So the pointer, the first time it has moved to my D, then I'm doing a break. Now check what it does, how it gets printed. See, it has printed me only C, the backward, because the pointer has moved to D. D is checking, okay, it has any previous elements. Okay, it has the previous element. So it has printed me C. So you can check, it has printed me your. See, when the first next time doing only to the D, then I'm just breaking the loop, then I'm coming out, then you can see the pointer is printing me only C. Hope that this is clear. This previous and this next, the pointer execution for the iterators
Yes,
or
sir.
the list iterator. Okay, okay.
Excuse me, sir.
Yeah, yeah,
Uh, uh, array DQ and array list. Array
yeah.
DQ acts as a stack.
Yes, yes, you can see this array DQ is type of a stack, but you cannot call it directly a stack. We have also a stack, different means data structure inside our Java. Uh, it can be a list. Okay, tell me what is the difference between a stack and a list? Do you know?
Um, like each node will be connected to the next node, right? In the linked list.
Yeah, that is
Like
correct. In
that's a
linked
pointer
list,
to the next node.
yeah, that is what is called a linked list is. If you
Yeah,
go to the data structure, a node is connected to the another node in a linked way. So,
yeah,
but remember, in a stack, inside your stack, there can be order, can be LIFO or FIFO, last in first out or first in last out. You can do in that way a linear data structure. That is a stack, right?
yeah. Stack is last in first out, right?
Yeah, yeah. Stack
Yeah.
is not last in first out. It can have the both. Stack, under stack, it is the superset, right?
Okay. Hmm.
Stack is the superset. It can have the last in first out or first in last out.
Okay. Okay.
Okay, stacks, and then you have the means queues.
Yeah.
Okay, we have done. You cannot say directly that our array list is particularly a stack, because in memory, if you are not mentioning a queue, Java automatically makes it a stack. Like if you are doing in a stack in a heap, that is automatically gets means the elements like this elements. Actually, I have done it in this linear way. Whenever I'm not mentioning a DQ, the elements are maintained inside a stack. See, this is one. Generally, this particular happens that in the memory it stores in this way, not in this fashion.
Okay. Yeah.
It creates a heap actually. Automatically in Java, whenever you are not mentioning anything, remember anything as a queue or something, it's always a stack. So that is a stack, and queue is something what we have shown you, that queue that you are doing a push and a pop. This is my queue. Whenever I'm pushing it, this A is going up to here, then E is coming here. Then when I'm popping it, this E is getting first popped.
Yeah. Array DQ is. I thought it was somewhat similar to stack. Array DQ.
No, you cannot say it's similar. Means similar to stack actually. You
Okay.
cannot say it. That is a queue. Means you can say,
Hmm.
means
Okay.
remember in C++ you have the pointers. Okay, But in Java, you do not have that concept of pointers. In C++, these queues or linked list or your stacks are particularly, you can just work on this particular this, you can move your pointers, and the real concept of stack and queue, everything comes there. But in your Java world, remember, we do not have these pointers. Maybe we can call this as a queue, or you can call this as a stack, but in real sense, you are just coding inside your to make it a stack like push or pop. I am doing it. But the real scenarios of stack or the linked list, that the data structure you have in your mind, those are implemented particularly in your pointers, that is your C++. If you have read the C++, the stack, queues, and everything would have come in a proper way. But in Java, in real world Java, those have removed your pointers. And remember, the real concepts of stack and queue has been, means the concepts is removed from your Java. So everything when you are storing is inside a stack.
Okay. Yes, sir.
Okay.
Okay.
And Monica, yeah, and let's go to the for each. Yeah, Monica, remember array DQ. Yeah, the question you have asked. See, I had written something. It extends your DQ. It's not extending your queue. It extends your DQ, double doubled queue. If you remember, if you have studied in DQ, what happens? If you remember, um, in a DQ, NQ means to insert an item into the back of the queue, and DQ means removing the front item. If you
Yeah.
have gone the DQ, it see it has the implements. It implements the DQ. It doesn't implement the queue. It doesn't implement the queue. It implements the DQ, and DQ is always meaning the removing the front item. So it happens this, right?
Yes, yes.
Whenever this is my DQ, this is my DQ, so it is DQ. So the my front item, this particular item, this front item,
Yeah,
this
it's pop.
particular front item, it is popping. That is a
Yes.
DQ.
Yeah, yeah.
You got it now?
Ah, yes, sir. It's like DQ is removing the first element in a queue. Yeah, I got it.
Yeah. So you can see that it implements this particular DQ.
Okay.
Okay.
Yes, sir. Yeah.
Okay. And the for each loop. Okay, we have done the for each loop. It's nothing to tell you anything more. Now let's go to the map. This is one of the most dynamic concepts of map. Map is something you have a keep your value. Let's concept. Whenever you are doing a map, something it happens. Suppose you are putting a map always comes in this way. This is your key and this is your value. The keys, this particular keys always should be unique. And this particular values, okay, for a particular key, suppose you have a particular key 1 2 3 4, and or anything, you can give a key as a string also. So you can give 1 2 3 4, your value is ABC. Then you can give 2 3 4 5 6. Values can be anything, values can repeat or something, but remember your keys should be always unique. The keys should be always unique. Suppose now you have already stored. Another is 4, 5, 6, 7. Here you are storing A, D, B. Okay, this is my values. So what happens now? Again, you are trying to insert or an element in your particular called key. You are inserting, suppose, FDR. So what happens for this particular this ABC gets overwritten with FDR. You cannot create two keys here. Let's take a program. The map is always something called unique keys, and it has the values. It is a mapping. Remember a map, just remember what is a map. Map is just, if you have read a set like this in mathematics, when you have read a set, it has also, is this a circle that I'm making? Okay, maybe when it is a set, you are doing a set mapping in this way. Remember, this is my a set map is done in this way in a mathematics. So this is a set A maybe. So we can call this particular set as a key. This mapping is done from key to value. Don't remember the mathematics that what is concept. This always these keys are unique. You cannot have two common keys. So it cannot have this particular called here. Suppose a key is 1, 2, 3, 4. Then you have this particular value called ABC. ABC. You have this particular values. Now remember, this is a values. Now if ABC is defined in another key, then this particular system that comes, this ABC, again is stored in this way. Suppose this is there, 5, 6, 7. Suppose this particular key. So this is a map. This way my key pair values are stored. So if we do a program, any program using a map, so we can check a program, and remember we can do this map interface. This is my map is my interface. This particular map is my interface, map interface we can say. Have I written the interface of a map? This was my collection interface. Now we have a map interface working with the maps. This is a different, this is an interface, and you have something called um, sorted map, tree map, and all this. So you have this particular called hash map. Hash map extends the class abstract map and implements the map interface. So let's do a program with a called map. Suppose let me give an example of the hash map. Hash map demo. Let me do a public static void main. Let me do this hash map, and my keys will be string and my values will be of double. And now hm equal to new has string and double. I need to import this java.util, I'm importing this. Now you can see, I have created a key and a pair value. This is something called this, and you can see you cannot use a primitive type here. Always we are using in the generics the particular called your wrappers or the classes. You cannot use a primitive type double here. Now let me just show you how to do something called put. I am creating a, suppose, on do, and I am doing a map like new double 3456.34. Suppose I'm doing a John Doe, and then I'm doing a Tom Smith. Maybe I'm just keeping the same value here, and then I'm doing something Jane. I'm just changing the value to something called 8, and then we can do Todd Hall 87. Let me do this. And Smith. Give it as a Smith. Let's check and let's print this. See, this is my key, this particular called key, and it is printing me this particular values, Smith, or this, or uh, this particular sets. This is my map, and see how it has printed me. Now see, if I had put something called here, if I had changed this value to the John Day and then something I had printed it, you check this particular value. Now, if I had printed this, now you check this. See, it has got updated. It's not creating a new one. This is my unique. So whenever I'm doing it again, I'm just assigning it again so it gets overridden. And you check this. This is how it's happening. And one thing you can see here, see, this particular this, you can check here, this is not my sorted key. Even when I have done it something called John Doe or Tom Smith, and it is not printing me in the same way that I have given. It has printed me in a random way. I do not know how this is getting stored inside, means in which sequence it is getting stored in my memory. But if you want to transverse this and get each element, you have to do with this concept called map.entry. Now remember this set. This is John Doe, Tom Smith, Jane, Todd Hall, or Smith. These are already a set. This particularly is a set that we have already read about this particular sets. These are mine. This is one of the sets. This is a key set, you can say. This is a my key set, and inside the key set you have this particular called values. So this is my key set that all the keys are present inside a set. Those are of string values. So In order to get this, we need to create a set which will have this particular called map dot entry. See, map dot entry. I know this is come. This is what I've given string, and this is my double. And let me create the key set. Suppose if I'm saying this is my key set of keys, you can say. And doing this, if you do this h dot, what I have done? Okay, this I finished it here. So you can say I'm taking the entry set. See, this is giving me this particular set. This is a set type that is returning me this. So if I had done a sys out of this particular set, let's check what it prints me. This particular set is giving me the same set. Remember, you can see the difference here. This is a map. You can check this. This is a map. And this is your particular called set. You can check the difference here. This is my set. You can check the bracket difference here, and you can get this particular thing. Now, if I had done a entry set, if I had done a for loop, suppose you have already got this particular set. Now, remember, I can do a iterator or I can do a for each loop. So let me do a for each loop. Suppose if I am doing this particular element, I know this is the particular element, making it as s, and I have this particular called entry set, that set of keys. Now I am transversing it. Why this is printing me set of keys is something called, okay, sorry, it should be, you can check this particular called map.entry string.double. It is my set of keys. So doing it this, I'm taking it as a s. This particular map.entry is your this java dot a map entry keep your value method returns a collection view of the map. This is my collection view of this particular map. So let me do, I am getting each element. So let me print out system sysout dot s dot the key and this particular value s dot get value. Now let us check. See, it is printing me the value. This particular, it's printing me the value. It's printing me the name. Suppose if before this, if I had done something this way, instead of suppose get something called Todd Hall. Suppose if I had done this way, and let me this, we can get the value by doing a get and put the key name here, Todd Hall. Then let me print this. Let me print this particular. See, it's going to print me the particular value. Why it is printing me null? Let me check. See, it is printing me null because this h I have given it as caps and it has something small. So for Todd with big H in the caps H, it doesn't have any value. Now you can see this Todd Hall, I've given a small h, it is printing me this particular value. So to print the particular value, you have to get the key here dot get, and you can do. Now if you want to transverse each of this, then you have to do in this way, that you are putting a set of keys, and then each element to be called in map dot entry, that is each element has been called using this particular s, like s dot get value. Or this is the way you can get your keys and values, or directly the values by one of the keys. So any question do you have?
No, sir.
Okay, so in the next class we will check with that called uh, one of the called tree maps, and we will check the difference. Then almost we have completed this. Then we can see difference between comparable versus comparator. Okay, how this is sorting is done and everything in the next class. And as Monica was saying, a traditional way to how this add or removes works. This is the traditional way. Even I can show you how this put is working. This particular put in a map is working this in a traditional way. Means inside the codes. We will show that and we will let you know. Okay. So for today, it's if you have any questions, please let me know.
No, sir. Yeah. Thank you, sir.
Okay, so today we are leaving it, and tomorrow we will go through this concept, and almost maybe tomorrow we will won't get time to do this traditional way. It takes time, but we will definitely go with these tree maps, comparable versus comparator, and then if we get time, at least we can do this particular add and remove and put method maybe in the next class. Then we will over with our collections. Then we can go to the files. This particular called files. Okay, that's it. And bye for today.
Yes, sir. Thank you.